Good morning, students. So in our DME class, we were discussing about sliding contact bearings. Till now, we have discussed the introduction part, the classification of bearings, and different types of sliding contact bearings, thick film bearings, thin film bearings, zero film bearings, hydrostatic or externally pressurized bearings, hydrodynamic bearings, and properties of the materials, different materials used in sliding contact bearings, and today we will discuss lubricants which we can use in the bearings. So the first type is the liquid type lubricants. In this category, you can use mineral oils and synthetic oils. Second category is semi-liquid, in which you can use grease as a semi-liquid lubricant having higher viscosity than oils. These greases are employed where slow speed and heavy pressure exist and where oil drip from the bearing is undesirable. So where you do not want oil drip from the bearing, at that condition you will use the grease because grease has higher viscosity than oils, and grease can be very suitable for low speed and heavy pressure conditions. Third category is solid lubricant where oil films cannot be maintained because of pressures or temperatures. So in the conditions where you cannot use oil as a lubricant, you cannot use grease as a lubricant, at that conditions you will use solid lubricants. They should be softer than materials being lubricated. The examples of solid lubricants are graphite. Graphite is most common of the solid lubricant, either alone or mixed with oil or grease. So in this diagram, you can see the outer circle, this blue one, is the bearing, and the inner circle is journal, or we can say shaft. O dash is the center point of the bearing, O is the center point of the journal, and the distance between two centers is eccentricity is written by E. Capital R is the radius of the bearing and small r is the radius of the journal. W is the load acting on the journal, and this journal is rotating in anti-clockwise direction. So these are the lines, center lines we can say. This is H naught, the gap between journal and the bearing, the minimum gap. So from this figure, we can define some terms that are used in hydrodynamic bearings. First one is diametral clearance. So diametral clearance is written as capital D minus small d. Capital D is the diameter of the bearing and small d is the diameter of the journal. So the difference between two diameters is written as diameter clearance. Next is radial clearance. It is written as capital R minus small r. That is the radius of the bearing minus radius of the journal. Or we can say capital D minus small d divided by 2. Or radial clearance is C1 is equal to C by 2. Third one is diametral clearance ratio. It is written as C by D, that is diametral clearance D minus D divided by diameter of the journal. Next is eccentricity. As I have already told you, eccentricity is the distance between two centers, that is center of the bearing and center of the journal. Minimum oil film thickness. It is the minimum distance between bearing and journal under complete lubrication condition. Its value may be assumed as C by 4. So this is H naught is your minimum oil film thickness and it is generally taken as C by 4. Eccentricity ratio, it is the ratio of the eccentricity to the radial clearance. So eccentricity ratio can be written as eccentricity E divided by radial clearance C1. So it is called eccentricity ratio. It is written as upside short and long. If the ratio of the length of the diameter of the journal, that is L by D, is less than 1, then this bearing is short bearing. On the other hand, if L by D is greater than 1, then this bearing is known as long bearing. Next is wedge film journal bearing. So you can see a journal, or we can say shaft, inside the bearing, and there is oil in the space. So at rest, when your journal is at rest, there is a metal to metal contact between journal and bearing, that is at point A. Now your journal is going to start the rotation in anti-clockwise direction, and when it is going to start rotating in anti-clockwise direction, this contact point A shifted to contact point B, and there A and B, that is the angle. This is the point where the bearing was initially contact point, and this is the new contact point. Now the angle between A and B, that is angle AOB, is the angle of sliding friction. It is called angle of sliding friction. Now when your journal will rotate in anti-clockwise direction at high speed, then what will happen, that this journal will pull the oil from the space between journal and bearing to the space where it is required. That is, the metal to metal contact between the journal and bearing is removed, and the oil film will cover the journal from all sides. This concept is known as wedge film journal bearing. So let's see. When the speed of the journal is increased, a continuous fluid film is established. So at high speed, a continuous fluid film will be established. It may be noted that from D to C in the direction of motion, the film is continually narrowing and hence a converging film. So from D to C, this is point D and this is C. From D to C in the direction of motion, this is converging. So it is called converging film. A little consideration will show that from C to D in the direction of rotation, the film is diverging. So from C to D in the direction of rotation, this is diverging film. Another concept is squeeze film lubrication. The resistance of a viscous fluid to being squeezed out from between approaching surfaces is known as squeeze film lubrication. That is, the resistance of a viscous fluid from being squeezed out between approaching surfaces is known as squeeze film lubrication. Another concept will be bearing characteristic number and bearing modulus for journal bearings. The factor Zn by P. Z is viscosity, N is RPM, P is pressure. The factor Zn by P is termed as bearing characteristic number. It is a dimensionless number. The variation of coefficient of friction with operating values of bearing characteristic number are obtained by Mackey brothers. So this is the graph. This is the graph between coefficient of friction and Zn by P, that is bearing characteristic number, and this graph is obtained by Mackey brothers. The factor Zn by P helps to predict the performance of a bearing. So this graph we will discuss in our next video. Okay guys, thank you.